Algebra 1, Common Core, Unit 5, Section 4, the slope formula. So the previous lesson 5.3, we learned all about what a line was. And we learned that a line, is made up of a bunch of points, but to graph a line or to really know what a line is, you need to know its slope and its location. So this video focuses more in on slope. We talked a lot about slope in the last video, and we had 4 good examples in our notes about the different types of slopes. And those were the positive slopes where they go up and to the right. The negative slopes they're declines, they go down and to the right. Zero slopes for horizontal lines and undefined slopes for vertical lines. And one of the things that I tried to emphasize in this video also was when you're doing the slope to always remember y over x. It's rise over run. It's your change in the vertical axis followed by the change in your horizontal axis. So to help us determine the slope of a line, we know we can count the boxes up and over and so on, but what if we have just a pair of coordinates? What if we don't have a graph at all? What if we still need to know the slope? And so we have what's known as the slope formula. And here it is right here. We, again, still use the letter m to represent slope, and it's y2 minus y1 over x2 minus x1. And what we really mean by that is kind of like second point's y value minus first point's y value. We give you a example down here that algebraically determine and state the slope of a line containing these 2 points. And what they show you is that the first point here is going to be represented by x1 and y1, because we know that all coordinates are x comma y. So the first number can be thought of as x1, that's x1, and the second number is y1. And then the second point here, 1, 5, that's going to be x2, y2, where the first number is x1 and the second number is y2 and so on. So basically, we're going to subtract the points, but we subtract the y values, and we do second minus first. So our second y value minus our first y value. We see that here, y2 minus y1. Now, one thing I want to point out also is that y2 is not the same thing as y squared. The little 1 and 2 here we're talking about, those are subscripts, they're called. They're not exponents. It really is just a way of saying like y2 represents, second y. It's like the second coordinate's y value. So it's like the second coordinate's y value minus the first coordinate's y value. The second coordinate's x value minus the first coordinate. So you're subtracting the y's from each point and subtracting the x's from each point. You don't subtract x and y together within one point. It's always one from one and one from the other. So in the numerator, because remember slope is y over x, rise over run, we subtract the y's, and we do second minus first. So 5 minus 3, we see that here, 5 minus 3 is 2. And then we subtract the x's. Again, we also do second minus first, 1 minus negative 2. And don't forget that when you subtract the negative, you get that positive, that minus negative. And what this does is, that basically is our change in y. Y2 minus y1, that's your change in y, and your x2 minus x1, that's your change in x. So when we count boxes like up 3 over 2, something like that, when we count up 3, if I have 2 coordinates here, what we're doing is we're subtracting the difference in the y values. If this had a y value of 5 and this had a y value of 2, well, 5 minus 2 is 3. It's, up 3, well, we're subtracting the y values. That's counting the change in y. And over is the same thing as counting the change in x, is subtracting the x values. So, it's a formula that's not given to you, first of all. That's something that always needs to be pointed out. It's a formula that does need to be memorized. And it just takes a little bit of practice. I mean, the common mistakes people make is they put x on top because we like x to be first because it's alphabetically first. And when it comes to coordinates, x is first. But when it comes to slope, y is on top. And then people make simple algebra mistakes, 1 minus negative 2 or, negative 3 minus 5. They'll, mess up stuff with the signs and things like that. So you got to be careful. And, of course, your calculator can help you. So determine the slope of the given points here. So let's do a couple of examples. So first one. So remember, now the first coordinate we think of as x1 and y1. And our second one is x2, y2. Because that's a y, that's an x and a y value and an x and a y value. First point, second point. And we do the slope formula, which again up here for us, is y2 minus y1 over x2 minus x1. So y2, 0, so m equals 0 minus Now, this is something right here. This is that I want to point out. The x value here, the second y, I'm sorry, the first y value is -5. And that's what I'm subtracting. I'm subtracting that -5. It's not 0 minus 5, right? It's 0 minus whatever that number is. So when your x1 and y1s are negative, you end up doing a minus a negative. So that's a 0 minus -5. And on the bottom, x2 is 2 minus a -1. So if you're, subtracting a negative, that's a very common mistake, is people just like, subtract 1, whereas really subtracting a -1. So that's the type of stuff you have to be careful of. And just note that when your second number is negative, you're minusing a negative. And the rule for subtracting a negative is, keep, change. This ends up being really kind of like a plus. You change them both to plus signs, minus a negative. And so it's really 0 plus 5 is 5. And 2 minus -1 ends up being 2 plus 1, 3. So the slope here is 5/3. Second example, m equals. I like to do the arcs, almost like the distribution arcs, but that's not exactly what I'm doing. Sorry. So y2 minus y1 is going to be -2 minus 4. Right? It's not minus -4, it's minus a +4. So that's why it's just minus 4. But on the bottom, we have -2 minus a -5. All right, so this is a great example to illustrate what I was just talking about, that subtracting a positive is -4. Subtracting a negative is minus a negative. Here for -2 minus 4, think of this as combining two negative numbers. Even though, again, this is a negative, but because we're subtracting it, we can kind of think of it as. So a -2 minus 4. It's like a -2, -4 is a -6. Again, use your calculator for assistance if you need it. Get rid of that little slash over there. But here we have minus and negative. These turn to plus signs, not the sign that's in front of the number. But anytime you got minus and negative, that's when it comes to plus. That's why they say keep this, change. So this -2 minus -5 really is kind of like -2 plus 5. It's a negative and a positive, comes out to be 3. And reduce your slopes if you can. This comes out to be -2, but keep it as a fraction, so we'll keep it over 1. First one couldn't be reduced. Down here, we have m equals, y2 minus y1, which is going to be 1. Let me get rid of that little dot. 1 minus 3 on top, and 5 minus a -1. Minus -1 equals minus a negative on the bottom. So 1 minus 3 is -2 on top. 5 minus -1 is 6 on the bottom. Reduces down to -1/3. And then the last one here, m equals -5 minus a -1, -5 minus -1 over 4 minus 4, 4 minus 4. And, on top we have, normal looking, but we got to do that keep, change, -5 plus 1 is going to end up being a -4. On the bottom we have 4 minus 4 is 0. And maybe that kind of stood out to you right there, that these have the same x value. And if they have the same x value and the bottom subtracts to 0, this is what we refer to as the undefined slope, or no slope. And that means that this must be a vertical line. And we can also see that if we were to plot these points, on a little sketch, here's 1, 2, 3, 4. Well, 4, -1, and 4, -5. They have the same x value. So, yeah, they're going to be on top of each other. It's going to be a vertical line. It's also not a function when it's a vertical line. So, these other ones, real quick, if we go back at these, and we don't have to draw their sketches, but what do they mean? Like this 5/3, remember, that would mean from a point up 5/3. Up 5/3. So, it would be a positive slope like that. These next two are negative slopes, so they are going to go, this one's going to go down 2/1. Down 2/1. It's a negative slope. This one's down 1/3. So this one's a little bit flatter because, the greater the number, the more intense the slope, the more steeper the slope. A slope of 1/2 is going to be flatter than a slope of 5. So this one was down 1/3. But again, we can tell it's a negative slope. It's going down But you can compare slopes once you kind of know for steepness. The closer to 0, the flatter the slope. The further from 0, the steeper it is. All right, and then of course we said this was a vertical line because it was undefined. If you end up with 0 on top and a number on the bottom, that would be a case for a horizontal line. And we would see that instead of having the same x, they'd have the same y's. All right, so that's our slope formula. Like I said, it's really not a bad formula. It's pretty small. It's just y minus y over x minus x. But it is a very important formula. You can do a lot this year. You can do some of it in geometry, more again in Algebra 2. You'll see it in pre-calc, calculus, and beyond. So it's a very, very important formula that we use a lot in mathematics. See you.